A quadratic function can be written in the form y equals a outside of x minus h all squared plus k, where the axis of symmetry is x equals h and the vertex is hk. In other words, if I'm drawing this quadratic, the axis of symmetry can be found by directly looking at the value of that formula, of that h in the formula, and the vertex with h and k. In order to move a function from the general form, so the general form, like this quadratic here, is of the form ax squared plus bx plus c. In order to change that into this vertex form, we need to do the process of completing the square. That's how we do it. So we're going to have a look at this quadratic function here and complete the square on this function in order to put it into vertex form, and then easily be able to graph it. Okay, so let's write down the function and have a look at it. Y equals x squared minus 4x minus 1. Now, to convert it into vertex form, we need to complete the square. So to complete the square, we've got to focus ourselves in on, firstly, these first two terms. And we've got to imagine that those are the first two terms of a three-term quadratic trinomial that's a perfect square. In other words, what is the value? What is this third term here that I would put after it? That would mean that this is a perfect square. Now, when we were completing the square, the method we used was we took the b, which is this second value, and we halved it and then squared it, and that would find what that term is. So in this case, b over 2 all squared would be minus 4 on 2 all squared, which is minus 2 squared, which is 4. And so the value that we'd want on the end would be 4. So what we're going to do is we're going to add a value of 4 to this expression, but in order to keep equality, we need to also subtract a value of 4 on the same side. So let me show you what that looks like. So this line is equal to x squared minus 4x plus 4 minus 1 and now minus 4. So what I've done in one part of the expression, I've added a 4, and then I've subtracted a 4 just a little bit later. And that means that this side is still the same value, but I've just manipulated it so I can make a perfect square. So my next job is to take this and rewrite it as the perfect square that I need. And that as a perfect square is x minus 2 all squared. I'm now going to simplify the end part. Minus 1 minus 4, that's minus 5. And so now what I've done is I've converted what started in general form into this vertex form. And so reading off that, we can see that our h, which stands for our axis of symmetry, the axis of symmetry for this one will be 2, and our vertex will be the point 2 minus 5. So if I was going to do a quick sketch of that, I would know that my vertex would be at 2 minus 5, and my axis of symmetry would be at 2, and so it would be some parabola like that. The other thing to note just in our form here is that this a value at the front, the function of that a is like how steep the graph is. So if it wasn't just 1, then if it was 2, that would be even steeper. If it was a half, it would be wider. And if it's negative, then it would be concave down. So just like our a in the general form, it does the same thing.